Good day, everyone. So today we will just continue our discussion, and let's begin first with the combustion products. So, or what are the products of combustion? So when a fire occurs, uh, certain byproducts of fire or combustion, dangerous to human beings, will appear. So when a material or a fuel burns, it undergoes a chemical change. None of the elements, making up the materials are destroyed in the process, but all the materials are transformed into another form or state. So for example, when a piece of paper or when a paper are liberated, the remaining solids, takes on the appearance of a carbonized or charred flakes. So when a fuel burns, uh, there are four products of combustion. So first is what we call the smoke. So what is smoke? So smoke, which is made up of a uh, solid fine solid particles, and condensed vapor resulting from combustion. So smoke, of course, is encountered, at most fire. So it consists of a mixture of oxygen, nitrogen, carbon monoxide, carbon dioxide, that has been released from the materials involved. So uh, the contents of smoke, will vary depending on the exact, material that is being burned. So smoke, may range also in color from deep black to white, depending on the materials being burned. So depende yan on the fuels or material na nasusunog. So for example, on the liquid fuels, generally they gives off uh, black smoke. So oil, paints, tar, rubber, and also many plastics also gives off dense smoke. So ano ba yung mga dangers of smoke? So first, of course, it curtails the breathing, and also it limits the working ability of the firefighters. So let's go to next. So for black smoke, with deep red litmus flames, they are the indication that the fuel used, in the fire are maybe tar, plastics, rubber, or other petroleum products. And also for greenish yellow flame, it is the result when when a fuel is used, when the fuel used is manganese or chlorine. For bright reddish yellow flame, which indicates that calcium is used. So for heavy brown smoke, with bright red flames is the indications that nitrogen products were used in the fire. For white smoke with bright red flames indicates that magnesium is used. Black smoke with red and blue-green flames would specify that asphalt, were used in the fire. And for lavender or purple flames would show that potassium was used in the fire as fuel. So another products of combustion, includes the fire gases. So fire gases, these are those refers to those gases, that remain when the product of combustion, are cooled, to below normal temperature. So gases, that is formed, or that are formed by a fire depends on many variables. So like it depende yan sa chemical composition of the burning materials. Second, depende yan also on the amount of oxygen available for combustion, and depende yan on the temperature. So what are the examples of the fire gases? So first is the carbon dioxide. So, sa mga wood products, okay, na nagko-contain ng carbon, of course, okay, thus they produce a carbon dioxide, okay, when burned even in small fires. So, yung mga carbon dioxide, they are colorless and tasteless and highly toxic, okay. So, one of the suggested precaution, okay, is never enter the suspected area without the breathing apparatus. So second example is the carbon monoxide. So one of the most dangerous, okay, byproducts of fire or combustion is due to the unburned particles of the fuel. So when leather, hair, okay, fabrics burn, okay, chemicals produces fumes. So carbon monoxide is also a colorless, okay, a odorless, and a highly toxic. Okay, so for about 0.2%, okay, by volume, can cause death in 30 to 40 minutes. So carbon monoxide also is a highly explosive, okay, ranging from 12 to 14% of sudden ignition of the air, okay, that will cause an explosion. So for ashes and embers, so it is by a product of some class of fire. So sa mga class A, okay, they lives or they always leaves ashes and embers. Whereas sa mga class C, okay, they may only leave small amount. Okay, and sa mga class B naman, they never leaves ashes and embers. So for next is for hydrogen sulfide. So when the materials, okay, like rubber, skin, hair, wool, meat, okay, are burned, okay, uh, one of the products of the uh, products na napoform niya is hydrogen sulfide. Okay? Hydrogen sulfide, it is colorless, okay, highly toxic gas that smells like a rotten egg. So let's go to next. Okay, flames. So flames, okay, are the incandescent gases which accompanies a rapid oxidation of any combustible material. So flame, it is visible, a luminous body of a burning gas. So when the burning gas is mixed with the proper amount of oxygen, the flame becomes hotter, okay, and less luminous. And the loss of luminosity, okay, is caused by a more complete combustion of the carbon. So next is heat. So heat, which is always measured as high temperature in a normal result of combustion. So it is also the product of combustion, okay, that is responsible for the spread of fire. So it is also the direct cause of burns, dehydration, heat exhaustion, and also the destruction of property. So yan yung mga products of combustion, okay? The flames, the smoke, the fire gases, and also heat. So let's go to next, fire behavior. So for behavior, okay, such as the thermal or the thermal imbalance, okay, are those activities wherein the fireman, okay, and investigator should be acquainted or familiar with. So for thermal balance, it is the normal behavior when the fire is undisturbed. So it is the natural condition, okay, created by fire or the normal movement of the fire, okay, in a building or structure. While thermal imbalance, it is abnormal, I should say, abnormal movement of fire, okay, due to the interference of a foreign matter. So the thermal imbalance, okay, this is often confuses the fire investigator, okay, in determining the exact point where the fire is originated. So Yan yung behavior ng fire. So, meron tayong dangerous or the fatal behavior of fire. So, ano yung mga yon? So, first is backdraft. So, backdraft, again, it is the sudden and the rapid, violent burning of the heated gases in a confined area that occurs in the form of an explosion. So, backdraft, okay, may occur because of improper ventilation. So if a room, okay, is not properly ventilated, okay, highly flammable vapors, okay, may be accumulated such that, okay, when the door or window, okay, is suddenly open, okay, the room violently sucks, okay, the oxygen, and a sudden combustion occurs, okay, which may happen as an explosion, okay, and the explosion is the result, okay, when the air or oxygen is suddenly introduced, okay, in an area where there is a tremendous amount of incomplete products of combustion. So backdraft, this is a dangerous condition that usually results to the fatal behavior of fire. Okay, and backdraft, this may happen during a smoldering phase of fire. So what are the characteristics of a backdraft? So yan, fire gases are under pressure. Okay, existence of black smoke that is becoming dense gray yellow. So confinement of excessive heat, there is a little flame or no flame. Smoke leave the building in puffs or by intervals. So windows are smoke stained. Okay, also muffled sounds are heard inside the building and violent rushing of air inside when opening is made. So a backdrop, okay, may result, okay, if someone opens a hot door. Okay, so this is why the firefighters are trained, okay, to touch a door with their bare hands, okay, and feel its temperature before opening it. So yan yung backdrop. So second is flash over. So when we say flash over, it is the sudden ignition of accumulated radical gases, okay, produced when there is incomplete combustion of the fuel. So it is also the sudden burning of accumulated free radicals, which is initiated by a spark or a flash, okay, produced when the temperature rises until flash point is reached. So when the temperature, okay, reaches its ignition temperature of the materials, okay, flashover occurs. So the flames instantly flash over the entire area. So when we say flash over, it is the stage in the development of a continued fire, okay, in which all the exposed surfaces reach its ignition temperature and fire spreads rapidly. So flashover, okay, occurs when a room or the other area is heated enough, okay, that the flames sweep over, okay, the entire space. And this happens, okay, during the pre-burning phase of the fire. So, yun yung flash over. So, next is bite back. So, bite back, okay, it is occurs when the fire resist extinguishment operation and become stronger and bigger instead. So, bite back, okay, occurs when the uh, firefighters use the wrong firefighting tools in extinguishing fires. So one of the good example of this is the extinguishment of fire involving petroleum gas, okay, through the use of water. So the fire becomes bigger and stronger instead, okay, because of the addition of water. So to extinguish this kind of fire, okay, firefighters should use dry chemical powder. So the dry chemical powder, okay, works to interrupt the chemical reaction of the fire. So that is bite back. So next is flash fire. Okay, so flash fire, it is better known as the dust explosion. So this may happen when a metal, okay, is completely covered with dust. Okay, this is going to be hit by a lightning. So the dust particles, okay, covering the metal, okay, burn simultaneously, thus, okay, creating a violent chemical reaction that produces a very bright flash, okay, followed by an explosion. And that is what we call flash fire. So, yan yung mga fatals or dangerous behavior of fire. So, next, again, heat. Okay, so aside from the sun, there are four sources of heat, namely the chemical, electrical, nuclear, and mechanical heat energy. So, yan ay na-discuss na in our previous discussion, but nuclear heat energy, it is one of the product of splitting or the fusing of atomic particles, or ito yung tinatawag nating fusion or fission. Okay? So the tremendous heat energy in a nuclear power plant, okay, produces steam, okay, to turn steam turbines. So when more heat is produced, okay, than is lost or transferred, okay, there is a positive heat balance. So when more heat, okay, is lost than is produced, and there is a negative heat balance. So let's go to next. Heat units. So uh, first is the calorie. So calorie, it is the amount of heat, okay, energy needed to raise or increase the temperature of 1 gram of water, okay, is by 1 degree Celsius. So 1 BTU is equals to 252 calories. So BTU, okay, is an acronym. So it stands for the British Thermal Unit. So it is a form of a measurement that measures energy. So second is the latent heat. So when we say latent heat, this refers to the amount of heat absorbed by a substance. So when a substance came from solid to a liquid and from a liquid to a gas. So it is the heat, okay, necessary to change the state of a given substance. Okay, latent heat also is the amount of heat, okay, transferred during a phase change, and it depends primarily on the substance, okay, and its states. So next is the heat of fusion. It is the quantity of heat necessary to convert solid to liquid. Okay, and heat of vaporization, it is the quantity of heat absorbed when a substance is converted from liquid to gas. And also the sublimation, it is the process of changing from solid to gas. So let's go to next. Heat transfer. Okay, so heat can travel, okay, throughout the building by one or more of the three methods, okay, which is the conduction, convection, and radiation. So the transferred heat, okay, not only the facilities that spread the fire, okay, that spread of fire, but also, okay, starts a fire that is not directly related with the first burning. So what are those, the means of the heat transfer? So first is conduction. So one of the ways a heat moves is known as conduction. Okay? Conduction, it is the transfer of heat from a region of a higher temperature to a region of a lower temperature by increased kinetic energy. So this increased kinetic heat energy is passed from molecule to molecule. So conductors are the materials that heat can pass through. So, and take note, not all the materials are good conductors. So I have this illustration. So Clemente is making soup. So she is using a silver spoon to stir a mixture. So the longer she shits and stirs, the hotter her spoon becomes. So because Clemente, okay, was in Mrs. Stinson's the science class, okay, she knows that this is not only because silver is a good conductor of heat, but also because the heat is being conducted, okay, from the hot area of the soup, okay, to the cold area of the spoon. So in order not to get burned, okay, Clemente switches to a wooden spoon, okay, which is the poor conductor of heat. And take note, okay, poor conductors are also called insulators, okay, since heat, okay, flows through them slowly. So this is why houses that are insulated, okay, stay warmer in the winter. Okay, so the heat is trying to pass through the walls, okay, to the lower temperature outside, okay, but because the materials in the walls are insulators, okay, so the rate of conduction is not fast. So let's go to next, convection. So convection, it is the transfer of heat, okay, through a circulating medium, okay, usually air or liquid. So heat transfer in convection is chiefly responsible for the spread of fire in the structure. So convection occurs, okay, when a liquid or gas, okay, is in contact with a solid body, okay, in a different temperature, okay, and always accompanied by the motion of the liquid or gas. So it involves the motion of water. So it occurs, okay, when a liquid or gas, okay, is in contact, okay, with a solid body, okay, at a different temperature and is always accompanied by the motion of the liquid or gas. So let's go to next, okay, radiation. So in the early 90s, okay, the German Max Planck, okay, formulated this form of heat transfer. So he wrote that all substances emit radiant energy, okay, simply because they have a positive absolute temperature. So radiation, it is the process of heat transfer by means of infrared radiation, okay, or a form of electromagnetic wave. So electromagnetic waves, okay, do not need any material medium, okay, for their propagation. Okay, space is almost completely empty. So the sun's heat, okay, cannot reach us, okay, by convection or convection. Okay, convection, okay, because electromagnetic waves, okay, don't need a medium. Okay, they are able to travel through space. So anything above, okay, the temperature of absolute zero is absorbed by darker surfaces and reflected by light surfaces. So this is why people wearing darker clothing in the summer are hotter, okay, than those people wearing white or light clothing. Okay, those who wearing black, okay, will absorb the radiations and therefore their temperature, okay, will rise. So in radiation, okay, it does not require, okay, contact or the presence of any matter between the bodies. Okay, so the radiant the radiant heat moves in waves and rays, okay, like the sunlight. So the radiant heat, okay, travels the speed as does as the visible light, okay, such as the 186,000 miles per second. So next is the heat measurement. So the heat of a given material is measured by its temperature. Okay? A material is made of a minute particles called the molecules that are in constant motion. Okay? So the temperature of a material is the condition, okay, that determines whether it will transfer heat to or from other materials. So the sensation of warmth and coldness of a matter on contact is determined by the property is known as temperature. And a thermometer, okay, it is the instrument, okay, used to measure temperatures, which can be commonly expressed in degrees Celsius, okay, Fahrenheit, Kelvin, or absolute. So next. So again, temperature is a measure of the degree of molecular activity, of a material compared to a reference point. So it is measured in degrees Fahrenheit or degrees Celsius. So what is Fahrenheit? Okay, so Fahrenheit is 1 is to 180, the difference between the melting point of ice and the boiling point of water. So in the Fahrenheit scale, used in English-speaking countries for purposes other than scientific work and based on the mercury thermometer, the melting point of ice is 32 degrees Fahrenheit, while the boiling point of water is 212 degrees Fahrenheit. So let's go to next. Centigrade. So centigrade, it is also known as Celsius degree or degree Celsius. Okay, it is 1 over 100, the difference between the temperature of the melting ice and the boiling water at 1 atmospheric pressure. So on the centigrade scale, the boiling point of water is 100 degrees Celsius and the melting point of ice is at 0 degrees Celsius. So Celsius scale is widely used, throughout the world, particularly for a scientific work. So it was superseded officially in 1950 by the International Temperature Scale. So next is absolute or Kelvin. So it is the same scale as Celsius degree. But the boiling point of water is 373 and the melting point of ice is at 273. So in the Kelvin scale, the most commonly used thermodynamic temperature scale. So 0 is defined as the absolute zero of temperature, that is negative 273.15 degrees Celsius or negative 459.67 degrees Fahrenheit. So let's go to next, the Rankine scale. So another scale employing absolute zero as its lower point, is the Rankine scale, in which each degree of the temperature is equivalent to 1 degree on the Fahrenheit scale. So the freezing point of water on the Rankine scale is 492 degrees Rankine and the boiling point is 672 degrees Rankine. So Rankine scale, it was introduced, by a Scottish engineer, a William John Maghorn Rankine. So that's all for today. So thank you for listening and God bless.